And welcome to my YouTube channel. This will be another video presentation where I'll be fiddling around with or testing another AC based appliance. In this case, this motor that you see right here. This is another motor that was salvaged from a broken room heater. It comes also with its allotted heating element, but this one won't be tested in this video presentation, even though it is a working one. So again, I'll be using the services of my homemade Variac device, and for voltage references, my digital multimeter VoltCraft VC404. I'll be using an extra greenish Alligator clip for grounding because again this motor doesn't have another wire sticking out of it for ground, so I'll have to improvise once again. And in this video presentation, another guest appearance by this massive Vise, to which I'll be probably again putting this motor inside. All the connections will be secured by my screwdriver into this coupling, where I have added two special metallic connectors onto which these two connectors from the motor will be plugged into. So this will be much more convenient for testing, unlike in the previous video. Again, this is the room heater from which that motor was salvaged from. This is how it looks like, an ordinary one. You can probably see inside a little bit. Maybe if I flip it. Because of this grid mesh, you cannot really make out. But this is where the motor would be secured onto. So that is how that appliance looks like. In my case, again, this motor from which it was salvaged from, the enclosure of the room heater was severely damaged. So as the procedure in my video presentations in regards to testing AC based appliance goes, now I'm just going to show you the motor itself, how it looks like. So this one has, still it's a two-bladed fan, or yeah, the fan or the propeller. I don't know whether this one is easily detachable like in the previous video, so I probably won't be making a two-part video presentation. I'll be just putting this motor into that vise and we'll start testing right away. After, of course, I remove this heating element off it. So this is from the back. So here you would unscrew these two screws and the heating element would come off. So this is a standard heating element, 1 kilowatt option, and of course the additional kilowatt as well. So altogether 2 kilowatts, and you can switch from 1 to 2 kilowatts. And this is also, in perfect condition, but I won't be testing this for the purpose of this video presentation, only the motor. So now I'm just going to remove the heating element of the motor and we'll have a much more closer look at the previous. So this would be, again, the back side of the motor. So here you have, of course, the winding. You don't have a sort of a notch on the shaft, so how do you remove this propeller is for me a little bit unknown. Now this is some of the information etched onto the metallic body of the motor, or on the stator, and here a little bit on the sticker. It's probably the model Here you can barely make out this is 220 volt motor, but the rest of the information is a bit scratched off. But you know, overall speaking, it's nicely preserved. Oh, here you have the indication in which direction the propeller would spin, or the shaft. And the shaft, of course, has the same diameter, or is of the same diameter like in the previous video, so around 5 millimeters or 4.5. But you know, overall speaking, it's nicely preserved. Here a little bit you have some of this, and it's not rust, but probably just dust combined with humidity. It's going to probably just be cleaned off here as well. So let's look at the connectors. So these are the connectors on the motor. I think these are the same ones, well, a little bigger, as in the previous video where I was testing another motor of this, or of these characteristics. So MF1563 connectors. So that's it. Now, as usual, I'm just going to connect everything up, power on the variac, put the motor into the Vise, set up the multimeter, and then we'll continue from there on. The variac is turned on, powered on through this black input power cable, which is attached into this AC power cord, and through the cable here that is inserted into my AC wall socket, and then of course through this white cable behind it, the output variable AC voltage will be generated. I have also connected the test probe leads of the multimeter into that coupling, which we'll see in a couple of moments, and the multimeter itself has been set in the correct measuring range. I will also zoom in on that. And of course, naturally, the motor has been placed into this Vise, so it will be stable when I'll be testing it, because you know, I just cannot exactly like hold the motor in my hand while I'm fiddling around with 220 volts, even though everything is grounded. You know, I don't want to lose an arm, a wrist, or any other limbs of my body, so I have to use this Vise in order to make the testing go smooth, but most importantly, that everything is safe. So now I'm just going to zoom in on the wiring behind the Vise, and we'll have a closer look. Now this one end of the Alligator clip has been clipped onto the enclosure, or the metallic stator of the motor, in order to create one side of the ground connection, while the other part is located right around here. So the wire goes a little around the Vise itself, because it shouldn't be anywhere near this propeller. So you know, if this was to sever the ground, that probably wouldn't be a good idea. So the wire or the Alligator clip, the wire goes a little bit around the Vise and is then connected onto this end of this wire, which of course then goes into this coupling. And then on the other side you have this standardized color coding, the yellow green wire, which indicates grounding. And then of course these are the wires for the actual motor. This is where you would put in your AC, and these are already connected onto these two connectors, which are inserted into this coupling. And onto these connectors I have also attached my test multimeter probe leads. Again, you know, polarity here doesn't matter. I could also switch them, but it is important that these two brass nickel-plated connectors are securely in this coupling, because I wouldn't want this, to come loose and create a short at 100 volts or even lower. But that would probably just blow up the fuse on my Variac, so nothing dangerous would happen. But nevertheless, and of course the wires of this motor, they have to be curved a little bit, so when the propeller spins, that also the propeller wouldn't sever the wires and also create a short. So I have to be also careful on that. So this is how this looks like behind the Vise, because when I'll be testing this, you won't be able to see the wiring, because I have positioned the Vise and the motor, so if this propeller would by some chance become loose and would fly off, it wouldn't fly in the direction of the camera, or of course even more importantly myself. It would go towards the Variac or towards the wall. So now I'm just going to zoom in on the multimeter and then we can start playing. So the knob on the multimeter has been set in the AC voltage measuring area, to be precise 750 volts AC, because, well, this motor is rated to work at the wall socket voltage 220 volts, so we'll be going beyond the 200 AC volts parameter, so always choose higher. So I have it set in the 750 volts AC measuring range, so that will be more than enough. So I have repositioned the camera to give you a maximum good overview on the entire testing of this motor. Also you can have a much more clearer view of the Vise, and of course the multimeter is on this side. I have also positioned myself on the right side of the camera, so it will be much more convenient for me to turn that gear or improvised knob clockwise in order to start increasing the voltage. So we'll start with the usual 50 volts AC and see if we have any movement on the rotor. So let's go. So 50 volts and nothing. Let's see if we spin it a little bit. Still nothing the other way. Yeah, also nothing. So we'll go up again by 50 volts. Interesting. Will it spin? I think it is moving, but I think very, very slowly. So we could say that at 80 volts AC you have very, very small movement on the blade or the blades, the propeller. Let's see if we gently push it a little bit. No, it actually stopped. So let's go up again. So again, some movement at 84. So definitely it starts to move somewhere between 84 and 87 volts. So we'll take the golden middle, 85. Definitely. So we have rotation at 86 volts AC. Nice. So we'll go to 100 and then from then to 150 volts. So the motor spins nicely at 100 volts. It's also still quiet, unlike in the previous video presentation. Alright, let's go to the next level. Alright, we're at 150 volts, and you cannot really hear the motor. Maybe even the ball bearings are really good, because in the previous video presentation when I did, I think the motor, even when it was at this voltage, you could hear it. Maybe the ball bearings in that motor were a little more torn out or worn out, because this one is really quiet. You can't hear nothing. So we'll go 200 volts. Now you can start to hear it. So we're at 200 volts AC. Now you can actually hear the motor running, the vibrations. Let's see how it is with heating, if it is heating up. I don't know, it's actually cool. But of course, as I mentioned in the previous video, the Vise also works as a sort of a heatsink, because you have metal touching metal. So let's go to the nominal voltage, 220 volts. So this is it. 220 volts. I don't know, maybe we can go a little bit even higher. Let's see what happens. Let's go to 130 volts. So even at this voltage, the motor works nicely, no problems at all. So this is the end of this video presentation on testing this AC motor, which was taken out from a broken enclosure Vise room heater. It also of course comes with the preserved or working heating element, you know, the one here. This is how it looks like when I have taken the motor out. So this one is also in good order, in good condition, functional. But of course this wasn't tested. Both parts can ergo then be used as replacement parts in another broken or faulty room heater, or for other electronics projects. If you learned something new in this video presentation, leave the like button on or checked. If you want to ask a question, leave your comment in the comment section below. Share and subscribe. So this is David, signing off.